Hello everybody and welcome to our new video training package of Abaqus. Lemaitre damage, then in Abaqus, a comprehensive and example-oriented package for advanced Abaqus and finite element users. Let's look at its content in this 10 minutes demo. If you want to start analyzing your projects in Abaqus, it is better to save your time by watching this demo and making your decision easier. Don't waste your time watching amateur and weak videos on YouTube.
In this workshop, we are going to implement the Lemaitre damage using the VUMath subroutine. In the first part of this package, we provide an introduction to the Lemaitre damage model. This introduction includes damage mechanics and contains the method of Lemaitre damage model. Chapter 2 will talk about writing the VUMath subroutine, which includes a flowchart, testing the subroutine on an element, and verifying. The final chapter is devoted to workshops to implement this subroutine. One of the prerequisites for this package is learning UMath and VUMath packages. This package is especially to implement the elastoplastic damage model in Abaqus software using VUMath subroutine. Next packages will teach how to simulate more advanced damage models with UMath and VUMath subroutines. This package includes more than 60 minutes of educational videos including theories and tips related to simulation and subroutine. Also in this package, practical examples are prepared for using these subroutines.
All educational files such as subroutines, text files, simulation files are provided for you. First, we talk about continuum damage mechanics, abbreviated to CDM. In this video, we are going to validate the written subroutine. We verify the subroutine with an example. And SDV2 is the damage parameter. The results are quite similar to the manual results.
In this workshop, we present a cylindrical deep drawing analysis with the implementation of the Lemaitre damage model written by the VUMath subroutine. In deep drawing analysis, we have 4 parts: punch, blank holder, forming die, and sheet. The sheet is made of copper and its mechanical properties are Young's module, Poisson's ratio, and density, which their values are presented.
Now you can see the process from the beginning till the end with a better graphical view and detect the critical segments. So we completely simulate and analyzed the deep drawing process. Thanks for watching. Our support is one of the main advantages of 3D printing simulation in Abaqus package compared to other Abaqus tutorials on the web. I hope you have got enough information about this package, but don't worry at all. If you have any questions about this tutorial, ask us via support@caeassistant.com.